last video in chapter 5 is this. So we examined equivalent circuits and elements, which are serial equivalency, parallel equivalency, Thevenin-Norton equivalent circuits, and the application of these circuits. Now we came a new subject called superposition theorem. So it is not directly related to the equivalent circuit, but you might consider it as indirect usage of an equivalent circuit. So going into the details, what is that superposition? It says as a theorem, if there are more than one independent sources in a linear electrical circuit, like this, there are two independent sources in it, then the solution of this circuit is the sum of the solution where only one independent source in while the others are deactivated. That means now, when you remove this independent voltage source, find the currents, and then put that independent source in and remove the other one, find the solutions. Addition of those two gives you the solution that you found while these two independent sources in. Maybe I can explain to you through an example that makes it very simple. So look at this one. This is the circuit given to us. If both of them in, you're going to find these currents. These currents, after your calculation, is going to be this value. You can check it at home. And then, what the superposition theorem says, this is the circuit given to us. This. Now we are saying we are going to deactivate one of the independent source. In this one here in this circuit, we deactivated this 12 amp independent current source, deactivated. That means the current became zero, deactivation, open circuit. So I made it open circuit, and there is only one independent voltage source in my circuit. Find the currents here. That is I1 prime, I2 prime, I3 prime, I4 prime. So the next step, so the calculation results of these currents are given here. So in the next step, in this time, I am going to deactivate the independent voltage source, which is here. Deactivate independent voltage source means make the voltage equal to zero. We made it equal to zero. And keep the independent current source as it is. So for this case, the calculation of these currents are written here. Now what we are saying, what we calculated in those two, sum them up, you're going to end up with this. Let's do it for the I1. Here I1 is 15 amp, and this I1 prime here is 2 amp. Addition of those two gives you 17 amp. Here you are. So this is called superposition theorem. So this is easy to, mathematically we can easily say that if you have a linear equation like that, then B1 and B2 represent the two different independent sources. When this is B1, left hand side doesn't change, that doesn't change. If you take the B1, calculate X1, and keep B2, calculate X2, X1 and X2 addition gives you this linear equations solution. Mathematically, it is easy to see. In course, I will explain to you. Now, there is a conclusion that come out from this superposition theorem. This is a multiplication rule, it is called from time to time. So if we consider now, we said any more than one independent source, assume that there are two independent voltage sources connected in serial. So you're going to find the current of these, all the elements, current and voltages, while those two sources are in. According to the superposition theorem, if we remove one of them, so assume that these two independent voltage sources are identical to each other and connected in serial. So if you remove one of them, you're going to find the currents and voltages. And you remove one of them, that means the short circuit this, find the currents and voltages, and then keep this one in and short circuit this one, find the same current and voltages. So both of them in, that means your current is going to be multiplied 2 because these values are the same, isn't it? So that means short circuit this one, whatever you found, short circuit this one, keep this one in the same solution. Circuits are the same. And when the addition of those two solutions identical to the solution, that means 2 times the one of them. What does this mean in practice is this. If you've got a source has got, don't consider that 2, and Vt here, so you're going to find the solution. If you say that independent source is multiplied with M, that means all the current and voltages is going to be multiplied with M in your circuit. What does this mean is this. Assume that you've got a circuit and you've got one independent source, let's say 1 volt independent source in your circuit, and you analyze and find the results. If somebody tells you, if I replace the independent voltage source, not 1 volt, but make it 10 volts, what would be your solutions? The answer is easy. All the currents and voltages multiplied by 10. So that is the multiplication. You don't have to analyze the whole circuit once more. All you've got to do is to say whatever number you multiplied the source, all the current and voltages are going to be multiplied with the same coefficient. So that is the end of chapter 5. We have finished the equivalent circuits anti-superposition theorem as well. A new chapter is going to be related to the operational amplifiers, new element, introduction to our circuits.